We see the second question. In a particle moving along a curve in xy plane is at the position xt and yt at the time t greater than 0. The particle moves in such a way that dx over dt. We think dx over dt is vx, which means the horizontal velocity of the object. So basically, this velocity changes with time as a function. And the next thing, dy over dt equal to the ln of 2 plus t squared, which is also the other component, vy, the vertical velocity of this object. At the time t equal 4 seconds, the particle is at the point 15 position at this time. Okay, find the slope of the line tangent to the path of the particle at the time 4 seconds. The slope of the line tangent to the path is the value of the differentiation dy over dx, the rate of the change in the vertical position versus the x position. For example, we have the position of the object vary like this. At a specific time here, for example, here is the time 4 seconds. The tangent to this curve path is the path of the object. Okay, this is the tangent. This is the tangent at that position. So the slope of this tangent at this position, meaning the tan of this angle, is the differentiation dy over dx at that time, meaning after finding this differentiation dy over dx, we need to plug the value t equal 4 seconds into that differentiation. And according to the given statement of the problem, we do not have this thing dy over dx directly, but we can use the chain rule to find that thing. Dy over dx here is equal to dy over dt multiplied with dt over dx. Okay, and this second thing, dy over dx, is actually the inverse of dx over dt. So here we have dy over dt and multiply with this thing. Now we just put the given formula here. Dy over dt is the ln of 2 plus t squared, and the inverse of dx over dt, which is the square root of 1 plus t squared. The last step, we just put the value 4 into this equation. So at the time t equal 4 seconds, that value dy over dx is equal to the ln of 2 plus 4 squared. Okay, multiply with 1 over the square root of 1 plus 4 squared. And using the calculator, we get the value ln of 18 over the square root of 17, and it will be 0.701. Usually I just need to take 3 decimal places, that is enough. With the rate of change, we don't know the unit, meter per second or something, just leave it there. This is the answer to question A. Let's move on to the question B. Find the speed of the particle at the time 4 seconds and find the acceleration vector of the particle at the time 4 seconds. The speed of the particle at that time, that velocity v, will be equal to the square root of the square, the sum of the square of the two components, which means vx squared plus vy squared. Remember that thing? For example, we have a velocity vx like this, represented by a vector of course, and another component vy. In any cases, always resolve a vector into the two components, horizontal and vertical component. This is the total velocity, the actual velocity of the object. And of course, because these two components are perpendicular to each other, and so v is the square root of the sum of the square of each component. And this is simply Pythagorean theorem, right? So the next thing, we put this vx is the dx over dt, and then we square it and then add it with dy over dt and then square it. The next step, we put the given formula into this formula. Okay, dx over dt is 1 plus t squared, the square root of 1 plus t squared, and therefore when we square it, so that is 1 plus t squared, no more square root. Okay, the second thing, dy over dt. Dy over dt is the ln of 2 plus t squared, ln of 2 plus t squared, and then we square that thing, ln of 2 plus t squared, and then square it. So this is the formula for the velocity, the speed. The next step, we again need to plug in the value of the time into this equation at 4 seconds. Okay, the square root of this thing. 1 plus 4 square plus the ln of 2 plus 4 square, and all of this thing we need to square this ln. This is 17 plus the ln of 18, and of course we need to square this thing. It equal to 5.04. And of course the unit of this velocity probably is like meter per second. The next thing, we need to find the acceleration vector. The question is vector, meaning it has two components, ax and ay, represented by vector like this. This is ax and this is ay. We need to find those two components. Okay. As you might already remember, that the horizontal component of the acceleration is the differentiation of the horizontal velocity dvy over dt, differentiation with respect to the time. Okay, we say horizontal velocity differentiation, and that horizontal velocity is the dx over dt, and we take that differentiation another time, so that is the second differentiation of the horizontal position, which means d square x over dt square. And we already know that the dx over dt is the square root of 1 plus t square. So we need to take this differentiation another time with respect to time another time, okay, using the chain rule again. So taking the differentiation of this thing, we take the 1/2 to the front, and then the function 1 plus t square, the power will be 1/2 minus 1, okay, which is minus 1/2. And we need to multiply it with the differentiation of 1 plus t square differentiation, meaning that is 2t. Okay, so here at the back we multiply with 2t, and then simplify it. 2 divide 2, that's 1. So we have t over the square root of 1 plus t square. Okay, this is the x component of the acceleration vector. Similarly, we'll find the y component of the acceleration. Ay is the dvy, the differentiation of the vertical velocity, meaning the second differentiation of the position with respect to the time. That is d over time differentiation of ln of 2 plus t square. Okay, differentiation of this thing, ln. Again, we use the chain rule. Consider the whole thing inside a bracket. 2 plus t square is a function v. So differentiation of a ln function, like differentiation of ln v over dv, will be the 1 over the reverse, the inverse of that function v, which means 1 over 2 plus t square, and then we multiply with v differentiation, okay, which means multiply with 2t, and finally simplify it. We have 2t over 2 plus t square. So here we now have the two components, and the last step, we need to put in the value of the time 4 seconds into these two components. So ax at the time 4 seconds, ax is equal to here 4 seconds over the square root of 1 plus 4 square, divided the square root of 17, huh? And similarly, ay, the vertical component, will be 2 multiplied with 4 over 2 plus 4 square. It equal to 8 over 18. Simplify that. 9 divide 2, 4 over 9. So the acceleration has the two components, 4 over the square root of 17 and 4 over 9. So this is the answer. Find the y-coordinate of the particle's position at the time 6 seconds. We're given that the dy over dt is the ln of 2 plus t square. This is the vertical velocity vy, okay, and the y position will be equal to the integral y differentiation dt, taken the integral, the limit of the integral, so that we can determine the position can be taken from 0 to 6 seconds. 0 is the starting time, but it will be difficult because when we read again the statement of the problem, here we're given here an information that at the time 4 seconds, the position of the object is 1, 5, meaning the x coordinate is 1 and the y coordinate is 5. So instead of taking the integral from 0 to 6 seconds, we can change it to as follow: the y coordinate at the time 4 seconds, and then we add it with the integral from the 4 seconds to the 6 seconds, okay, of the vy vertical velocity with respect to the time. And we know that y4 here is already given the value 5, and we need to add it with this integral. So now we need to calculate this thing. Integral of 4 to 6 of the ln of 2 plus t squared dt. To calculate this integral, it will be pretty difficult, even though we can do that using integration by parts, but it will be very long. Instead, we can use the calculator, okay, to find this integration. Going to the menu 9, finite integral, and then I enter the lower boundary 4, upper boundary 6, and then enter the equation ln of 2 plus x squared. I'll use the letter x instead of letter t, okay, and of course I need to define the infinitesimal here as x also, and then just let the calculator do the work, huh? It will be equal to 6.57, and so the position at the time 6 seconds is 5 plus this thing 6.57, and the result is 11.57. That's it. This is the solution to question C. And the last one, question D. Find the total distance the particle travels along the curve from the time 4 seconds to time 6 seconds. That total distance will be the distance d will be the integral of the total, the equation, the function for the velocity, and taken the calculus with the time infinitesimal, the time from 4 to 6 seconds, okay? And this vt is a function of time, which is the x vector plus the y vector. The two components vx and vy are the, and we need to square it using Pythagorean theorem, okay, and add it with vy square, which means here we have dx over dt. It is already given, okay. We need to take the x square and then add it with dy over dt. Here's are the two functions of the horizontal and vertical velocities with respect to time. So to find this distance, we just need to put all of these functions into the integration here, okay, meaning this is the integral from 4 to 6 of the square root. Dx over dt is the square root of 1 plus t squared, okay. So when we square it, there is no more square root, but only 1 plus t squared. And the second thing is the ln of 2 plus t squared. And then we need to square this thing. Taking this integral with the calculator, we get the result. The distance that the object moved from the 4 to the 6 second will be the integral of this thing. Now use the calculator, huh? And then I will enter the equation, huh? Lower limit, upper limit, and then here the square root of 1 plus t squared plus x squared, 1 plus x squared plus the square of ln of 2 plus x squared, and then closing the bracket, close it again and put the square in, huh? Square of the ln, okay, and finally define the infinitesimal dx, okay, and we will get the result, which is 12.14. So that is it. This is the solution of the question 2. Thank you for watching and hope to see you again.